All right, we're going to start a brand new unit. It's called Solutions. And to start off the unit, we're going to start by talking about water. So the tasty water molecule. A long time ago, we talked about the Vesper shape, right? The Vesper shape. So the shape of water is what we call bent. Okay, so it's a bent shape. So you have an oxygen here, and you have two hydrogens that are attached to it. And so it is a bent shape. It has a covalent bonds between oxygen and hydrogen. That means they share electrons. Oxygen is what we call more electronegative. Than hydrogen, meaning it's more greedy for electrons. So it wants electrons closer to oxygen. That means that the electrons, right, the density, meaning it's actually closer to oxygen. So that's why water has unbalanced charges. Okay. If water has unbalanced charges, then that means one part of the atom is going to be partially positive and one atom is going to be partially negative. So hydrogen is partially positive and oxygen is partially negative. Okay, we say this because the electrons, remember, are closer to oxygen. They're closer to oxygen, making hydrogen partially positive. It's not fully positive. It doesn't lose them. It's just far away from the hydrogen. And what do we know about opposite charges in chemistry? Like opposites will attract. They love each other. So anytime they see a partially positive or partially negative, they will attached to each other like little magnets, okay? When we say that it has unbalanced charges, we say that it is polar. So water is a polar molecule. There is a positive pole and a negative pole, like a north and south pole in a magnet, okay? So the hydrogen and oxygens will carry opposite charges and they will attract each other. That attraction between a partially positive hydrogen and a partially negative oxygen is called hydrogen bonding. Okay, you can see in this picture here that this hydrogen is partially positive. This oxygen is partially negative, so they are attracted to each other. Ooh, my heart looks a little messed up. So they are attracted to each other. This is partially positive hydrogen with a partially negative oxygen over here. So they're attracted to each other. Here's another partially positive hydrogen with a partially negative oxygen. So they will like each other. Partially positive here, partially negative here. So they get attracted to each other. And so they will get sucked into each other. So when you see water droplets touch another water droplet, you will see that they will like attract each other very strongly, and that is called hydrogen bonding. Okay, so let's review some of the vocabulary terms that we learned. Okay, we learned that water is what we call polar because they have uneven sharing of electrons. Okay, between hydrogen and oxygen in water, the electrons are a lot closer to the oxygen. They're still sharing, they're just physically closer to the oxygen. So water molecules are attracted to other water molecules and because of the polarity. And if you have no unbalanced charges, if they are playing that tug of war evenly, then we call these compounds non-polar. And here's just another picture where you can see that partially positive and partially negatives are attracted to each other. Okay, so what exactly are solutions? Solutions are homogeneous mixtures. Remember what homogeneous means. They look the same all across, even though they're made up of multiple things. So let's recap some different types of solutions. Like a liquid solution is when you have a liquid in liquid, a gas in a liquid, or solid into liquid. So for example, you have chocolate syrup in milk. Those are different things, but when you mix them all well together, it looks like one uniform, same look all the way across. Here you have carbon dioxide in soda, okay? You can't see the gas per se, but they are mixed evenly across, so sodas all are homogeneous mixtures. They are called solutions. When you mix salt and water, that's also a solution. You can have gas in gas, so oxygen inside air is also called a solution. Or a solid into a solid, like when we talk about brass or steel. If you mix two metals together, they look the same all the way across. Like you think of your instruments, like, you know, your trumpet, right? Something like that, where the material looks the same all the way across. Now, every solution is made up of two components. So here are some vocabulary words. One is called a solute, okay, and the other is called a solvent. When you mix a solute and a solvent, that's how you get a solution, okay? And so how do you know the difference between a solute and a solvent? Solute usually goes into the solvent, okay? So if you look at this example right here, you can think of solute like salt and solvent like water. You put the salt into the water and then it evenly gets distributed across. So when you mix salt and salt water, it becomes a homogeneous mixture. We call it a solution. So here's a little trick right here. Remember that the solute goes into the solvent. Solute, if you look at this picture here, you can see that it is smaller than solvent. Okay, it's usually the smaller part, and the solvent is going to be the larger amount. Okay. Now, generally we call water the universal solvent because generally a lot of things are dissolved in water. They're mixed in with water, and so water will take that in and dissolve it. Okay? Solutions that have water as a solvent are called specifically aqueous solutions. And you remember seeing this because it's always abbreviated with AQ like this, right? Aqueous solutions. And so a lot of people had questions about what is AQ? That means something was mixed in water. So what's an aqueous solution? Like we said, like salt water is an aqueous solution. Okay, let's do some examples, okay, at the bottom here about which one's a solute and which one is a solvent. So here's example number 1. It says 10 grams of sugar and 40 mils of water. Okay, which one do you think is a solute and which one do you think is a solvent? Well, earlier we said that water is the universal solvent. So I'm going to put this here. Okay, and then we have sugar as our solute. So usually you put the sugar into the water. Remember, sugar goes into the water. So that's your solute and solvent. Okay, you try on your own the solute and solvents. You can pause here, and then you can check your answers. I'm going to go ahead and write them all out in just the next second. All right, so those are the rest of the answers to your solute and solvent. Hopefully you got all of those correct. All right, on to the next thing. So like dissolves like. What does this exactly mean? It means that polar substances dissolve in polar solvents. So we know that water is polar. So water dissolves anything that is also polar, right? Now, here's an example that you might remember. Like polar substances are what we call hydrophilic. Remember biology, right? They love water, okay? Okay, so polar dissolves polar. So you think of something that is polar, it will dissolve another thing that is polar. Okay. And non-polar things dissolve in non-polar solvents. Okay, so an example would be like gasoline would dissolve things that are non-polar, like oil. Okay, non-polar substances are what we call hydro. Do you remember if they hate water? Hydrophobic, right? So look at this example right here. Okay, so why do you think water and oil don't mix, right? It's because water is polar and oil is non-polar, so they will always have a separation like this, and they will never mix. So if you shaky oil and water, they will eventually separate out because water and oil do not mix because one's polar and the other is not, right? Okay. Okay, so how can we increase the rate of dissolution, basically how fast something dissolves of a given solute in a liquid solvent? Okay, so these are things that you commonly do all the time, and you just have to remember the vocabulary words that are associated with it. So, always think of an example. What is an example of you taking a solid and dissolving it in a liquid? So some people do like sugar in tea, or they think of like Kool-Aid, the powder into water, etc. Okay, always think of an example and ask yourself, how can I make this powder dissolve faster? Okay, and so there are things that you automatically, intuitively do. So what are those things? The first one is you agitate it. Okay, what does agitating consist of? It means to stir or shake it. Like a protein shake, right? Also, you can raise the temperature, right? Basically, you're heating it up. Like if you are putting sugar in cold tea versus hot tea, the hot is always going to dissolve a lot faster, right? The sugar is going to dissolve faster. Okay, what else can we do? We can do what we call increase the surface area. What does that exactly mean? It means to break it up, or to crush it. So if you have like a sugar cube, right? This is like a sugar cube, right? What can you do to the sugar cube to make it dissolve faster in your tea, right? You can always break it up into like small powder, okay? So the smaller it is, the easier it is to dissolve. Okay. Now, this next part right here is when we are talking about when the solute is a gas. So when we put a gas into a liquid, what's the example that you think of? Think of carbon dioxide in soda, okay? How do you like your soda? What makes it so good, that carbonation, okay? People generally like their soda very cold, right? That means we need to lower the temperature, okay? The colder it is, you have more gases inside this liquid. So you basically get more carbonation. But the hotter it is, you get less carbonation, and that's why it starts tasting really flat, right? All right, this last one is how else do you like your soda, right? You need pressure. Why do you think you hear that when you open up a soda here? Okay, it's pressurized, and when you open that soda, you have some of that carbon dioxide that comes out, right? So the more pressure you have, the more gases we can have inside our soda here. Okay, now don't be confused between this one, okay, solid in a liquid, and this one, which is a gas in a liquid, because this one needs to be cold in order for the gas to dissolve, like soda to taste good. But this one over here, we need to raise the temperature because we want the sugar to dissolve faster in our tea. Okay, so there's a difference between solid and liquid and gas and liquid. All right, so you'll be answering the questions on the next page for practice.